All right. Thank you very much. So we wish to start. Before we go into the lecture today proper, last week we gave some exercises. Remember, we said that our attendance to lectures, our exercises, also some tests and exams, or all tests and exams together form part of our continuous assessment. So we say we're going to take every exercise, test, and exams very, very serious and important. So we gave some exercises last week, and we said that today we will give some few moments or minutes for those of us who have done the assignment to present it or to submit it, and then before we make some corrections. So we'll start with you, Mr. Jason. If you are okay, you can present your own assignment so that we'll see.
No, the presentation is on Thursday, so today is Wednesday.
Okay.
Yeah.
The timetable has been rescheduled, and we only have
Yeah.
five.
I didn't get that information because I know I even chatted the present. I'm writing exams actually. I wrote exam today, but tomorrow I'll be free. So I didn't prepare any presentation. I was told it's Thursday, so I didn't do my presentation.
Okay. So what do we do now? Halim, are you there?
Yes, I'm here. Good evening.
So what do you see?
I think we should probably start the lecture for now. Then maybe when others join, maybe towards the end of the class, we can ask them to present the exercise, then show the solution for it. I
Okay.
don't know if that is better.
All right, fine. I think that's fine. That's okay, right, Mr. Jason? All right.
Yeah, it's fine.
Okay, so
I'll
let's go.
present today.
Thank you.
Yeah, yeah, yeah.
So I'm presenting now in a few minutes. Can you all see my screen?
Yes,
Yeah,
yes.
yes, sir.
Go on.
Yes, sir.
All right. So today in statistics for economics will be our lecture three, teaching this course with Halima. So for our today's class, we'll just give a brief summary and a revision of what we did in the last class. Then from there, it will now give form the basis to which we'll continue today's class. So in our last class, we talked about statistics. We talked about different types of data. We talked uh, we talk about data presentation. We talk about numerical measures of position. We say that the measures of position include the mean, the median, and the mode. We also talk about measures of dispersion. We talk about the range and the interquartile range. We also talk about the variance and standard deviation. We see this form basis the measures for dispersion. We also talk about measures for skewness, and we give the formula for skewness, and we also explain that when a data tend to be concentrated to the right, we say it is right skewed. And when a data set is tend to be concentrated to the left, we say it is left skewed. So today we'll be talking about um, numerical measures of skewness. We'll give some small review. We'll also talk about numerical measures of relative position. Under that, we'll be looking at the standardized values. We will also look at bivariate data. Then under that, we look at covariance and correlation. We'll see some examples. We will do some calculations, and then we will make some interpretation of covariance and correlation when a data set behave uh, in those ways. We also look at some key formulas that will form part of the complete revision of what we have been doing from the beginning of the class. And then we also look at some softwares, particularly the Excel. So look at the Excel options if uh, on how to solve some of these uh, questions, how to do some data presentation and get some statistics, maybe the measures of position, the measures of dispersion, and then also covariance and correlation. So if we are with our maybe if we are with our laptop towards the end of the class, we will use the opportunity to see how we can be able to use some Excel options to solve some of these problems to present data. Then we'll also see some exercises that will form the exercises for the next class. So uh, this table here, this histogram, gives us some features of some data. Uh, the data might not, we may not see the data here, but the important thing I want us to note is the distribution of the data. So this histogram here, this figure here presents us four different histograms that categorize or characterize some data sets. So the first histogram we see here is for panel data A is moderately skewed, and then here we see that the skewness is negative, that's 0.85. So we see the data, how the data is concentrated to one side. Then by the right here, we see another data having this here, this data here. We see that this is characterized by being moderately skewed to the right. Then here, the third data here, we see a data that is having a symmetric skewness. Most data that are usually symmetric are data that we term that are normally distributed. So most data which are normally distributed are usually symmetric, but usually it's difficult to see a data set that is symmetrically distributed. Whereas the panel data here in D gives us, here we see that, sorry, in the panel data C, we see that the skewness is 0. That is why it is symmetric. Here we see that the panel A, we see that the skewness is negative 0.85. That's why it is moderately skewed to the left. Then here we see that the skewness is positively 0.85. That is why we see that it is moderately skewed to the right. And then lastly, we see a highly skewed to the right data set here. We see that the skewness is 1.6. Now, numerical measures of relative position. So we're going to be looking at the standardized values. Now, another measure of relative position is the standardized value. The standardized value of an observation is its distance from the mean divided by the standard deviation of the sample or population in which the observation is located. Remember, in our last class, we talked about uh, standard deviation and variance. And then we see that the standard deviation is the square root of the variance. And we see that the variance is the sum of squares deviation from the mean of the individual observations from the mean. So the uh, standardized value is uh, is 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 the distance from the mean divided by the standard deviation of the sample or population in which the observation is located. So the standardized values of a set of observation from x1 to xn given by the formula here. So the standardized values is what we also call the z-scores. So the formula here gives us the standardized value. So we have z subscript I is equal to xi minus mu. Recall that mu here is the population mean, and then we say the X bar stands for the sample mean. In our last class, we have explained all those. So here the mu here, yeah, is the Greek alphabet that stands for the population mean. So the z-scores here is the sums of is the value xi minus mu all over the standard deviation, just like I've explained here. Now, for members of a population whose mean is mu and the standard deviation sigma squared are known, and zi, we have this guy here, zi equals to xi minus x bar all over s. This is the z-scores for members of a sample with mean xi, with mean x bar, sorry, and sample standard deviation s. So these two formulas are used as the standardized scores for the first one for the population mean, and then the second one for the sample mean. Now, the standardized value or z value of an observation is the number of standard deviations it is away from the mean. So that is actually what it measures, the number of standard deviation away from the mean. So we will look at once we delve more and more deep into the course, we will see um, how we can apply this course, where their usefulness, and how we can interpret them once we encounter some problems when we start using the standardized z-score. So bivariate data. Under here, we're going to be talking about covariance and correlation. When we hear of a bivariate data, bi means univariate data means a data set that is one dimensional. Bivariate means a data set that is two dimensional, and then multivariate means a data set that has multiple dimensional entries. So a data set that contains only one variable of interest, as will be the case with the wage data above, if the gender of each weight, remember the wage data that we used last time in our last class? Yes, that's the one we're talking about here. So, as will be the case with the wage data above, if the gender of each wage earner was not recorded, is called a univariate dataset. So, a univariate dataset is a dataset that contains only one variable of interest. Datasets that contain two variables, such as wage and gender, in the wage data above, we have seen the data set already, are said to be bivariate, so which means they have two variables of interest. And the consumer price index and inflation rate data presented in table 1.6 and table 1.7, remember, above are multivariate because they contain four variables. And those four variables from our last class include those four countries, because we looked at the inflation rate of four countries, UK, USA, Japan, and then Canada. And also, we also look at the consumer price indexes of those same four countries. So we see that they have four variable of interest. That's UK, USA, Canada, and then Japan. So that makes it a multivariate uh, data set. So I come again. We see that a univariate data set is a data set that contains only one variable of interest. A bivariate data set is a data set that contains two variable of interest. And when you have more than two variable of interest, we call that a multivariate data set. Thus far, we have examined numerical methods used to summarize the data for one variable at a time. Often, a manager or decision maker is interested in the relationship between two variables. In this section, we present covariance and correlation. So remember, covariance and correlation usually measures relationship between two variables. So here we're going to present covariance and correlation as descriptive measures of the relationship between two variables. So thus far, we have examined numerical methods used to summarize the data for one variable at a time. Often, a manager or decision maker is interested in the relationship between two variables. So we're going to use the covariance and correlation to estimate those relationships, to see how closely related these data sets are. So we begin by reconsidering the application concerning a stereo and sound equipment store in San Francisco as data presented in table 3.6 below. So we're going to look at the data presented in table 3.6. Let me quickly go to the data set, then I'll come back here so that we'll see what we're talking about. So this is data set in table 3.6. It is data for the stereo and sound equipment store in San Francisco. So here we see week 1 to week 10. Here we have week 1 to week 10. And then here we have number of commercials, which is X. And then we have sales volumes per hundreds of dollars, which is Y. So we see this data set has two variables of interest. And we want to see, often maybe we're interested to see, okay, what is the relationship? Maybe if there is more commercials, does the sales volume increase or does the sales volume decrease? So we want to measure the relationship between these two variables. As number of commercials of stereo means actually means sound, stereo and sound equipment store. So we want to know whether if they make more commercials, they get more sales volume, or if they make less commercials, they get less or more sales volume. So the correlation or the covariance will be able to give us how they vary and what their relationship is. So going back to the to this, we see that the store manager wants to determine the relationship between the number of weekend television commercials shown and the sales at the store during the following week. So sample data with sales expressed in hundreds of dollars are provided in table 3.6. We have seen table 3.6. It shows 10 observations. So our small letter n, which are the sample observations, are equal to 10, one for each week. So which means they have been taken they have been taken for 10 weeks. And the scatter diagram also in figure 3.9 will shows a positive relationship with higher sales y associated with a greater number of commercials. So we will see subsequently as we continue that the more the commercials, the higher the sales. So in fact, the scatter diagram suggests that a straight line could be used as an approximation of the relationship. In the following discussion, we introduce covariance as a descriptive measure of the linear association between two variables. So covariance is a descriptive measure of the linear association between two variables. So here is our table, the data in table 3.6, sample data for the stereo and sound equipment store. All right, for a sample of size n with observations, these are pairs of observations since they are data set that have two variables of interest. That's the number of commercials and then sales in hundreds of dollars. We have pair of variables x1 comma y1, x2 comma y2, and so on and so forth. So and so on and so forth. The sample covariance is defined as follows. So here, this is what we mean by x1 comma y1. Here we see that in week 1 we have number of commercials to be 2, and then and then we also have sales volume to be 50. So these are pairs of values. So this is x1 comma y1. And then for the second observation, week 2, we have number of commercials to be 5, and then we have sales volume of 57. So these are pairs of observation for the second observation. Pairs, they are in pairs. So continually till the week 10 here, as you can see. So the sample covariance is defined by the formula below. So this formula is for the sample covariance. Remember, we say we use small letter s to denote sample, and then the formula for the sample covariance is given by summation of the deviation from the first variable of interest multiplied by the deviation from the second variable of interest. So we have summation xi minus x bar times yi minus y bar. Sorry, this open bracket here is an error, but it actually means but the uh, only multiply we add the sum of the product of the deviation from the first variable and that of the second variable. So here we have in equation 3 divided by n minus 1. So this n minus 1 here is telling us that it's a sample of observation. So we're going to see the same formula for a population. We are looking at population. So This is it. So we will see how we'll be able to solve them as we continue. Now, so this is the scattered diagram that we were talking about earlier on for the stereo and sound equipment store. So here we see this scatter by the vertical axis. We have sales in hundreds of dollars, and here in the horizontal axis we have a number of commercials, which is the x-axis. So here we have a scattered diagram that lays side by side in two observations. So we see them in pairs. They are almost similar in pairs. So it laid them side by side as we have explained in as I've explained above. Now, calculations for the sample covariance. So here we see how to calculate the sample covariance. So here we have the observations xi's and then yi's. The xi's are the number of commercials. Here we have 10 of the observations. In total, we have 30 here. Then for the yi, we have sales per week. So we have from 50 down to 46. So the total gives us 510. So when we calculate the mean of the xi's, remember we gave the formula for mean, even though we're going to give a comprehensive summary of formulas for all the measures that we've been talking about since our last two classes. But we've already learned how to calculate the mean. So here, once we take the sum of deviations from the mean for all the xi's here, we have one for the first observation, two for the second observation, and so on to one for the last observation. So when we add all of them, we have 0. Then here, secondly, we have the same thing for the yi observations. And then finally here, we have the, the product of the two observations, which this was this. So the total is equal to 99. Now, note that the mean for x, that's for the number of commercials, is 30 divided by 10, which will give us 3. So the mean is 3. And then the mean, sorry, this is mean. The mean for the sales is 510 divided by 10, which gives us 51. So when we use equation 3, we obtain a sample covariance. So this is equation 3, even though we put equation 4 here, but this is gotten from equation 3. So we have this, and substituting the value for the sum here, we have 99 all over the sample. We have 10 observations in total minus 1. This gives us 9. So 99 divided by 9, once you press your calculator, you get 11 here. So let's interpret what the data means. A positive value for the covariance, that's covariance between x and y, indicates a positive linear association. So here we see that we have a positive value 11. So there is a positive linear association between the two variables. So just like we have explained earlier on, we say that if there's higher commercials, then the equipment store is going to experience a higher sale. That is, as the value of x increases, the value of y also increases. A negative value for the covariance, the sample covariance, indicates a negative linear association between the two variables x and y. That is, as the value of x increases, the value of y, sorry, this is supposed to be decreases. As the value of x decreases, the value of y decreases. So I'm going to make the necessary corrections later before I send out the, the material. So here is supposed to be decreases. The value of y decreases. And finally, if the points are evenly distributed across all four quadrants, the value of the sample covariance will be close to 0, indicating that there's no linear association between x, which is number of weekly sales, and y here, which is the sorry, x, which is the weekly commercials, and y here, which is the weekly sales. Now, population covariance. Now, just like we got the formula for the sample covariance, we also use the same formula for the population covariance. But here, we recall that the mean here is mu of x, mu subscript x, which stands for the mean of the population. And then here is mu of y, which stands for the mean, also mean for the population. Here, the mean of the weekly commercials, which is represented by x, and here the mean of the weekly sales, which is denoted by y all over n. You see, there's a difference between the that of the population uh, covariance and then the sample covariance. Here we have sigma instead of s for the sample is small letter s of xy, and but here for the population is sigma, while for the sample we divided by small letter n minus 1, while here we use the total population, which is n. A measure of the relationship between two variables that is not affected by the units of measurements for x and y is the correlation coefficient. So now, if we are looking for another measure that the variable is not affected by the units of measurement for x and y, we will use the correlation coefficient. So let's look at the correlation coefficient. The correlation coefficient. Let's not forget that also the correlation coefficient deals with bivariate data. So a data set that has two variables of interest. Now for the Pearson product moment correlation coefficient is defined as follows. That's the Pearson product moment coefficient is defined as follows. So usually we use small letter r of xy equal to s of xy, which is the covariance of xy all over covariance of x multiplied by covariance of y, where r of xy here is the sample correlation coefficient, the s of xy is the sample covariance, the s of x is the sample standard deviation of x, and then the s of y is the sample standard deviation of y. I've given all the formulas for to get all this. So this formula right here, equation 3.15, is the Pearson product moment correlation coefficient for sample data. So calculations for the correlation coefficient. So we're going to look at some calculations using the Pearson product moment correlation coefficient formula. Now, equation 3.19 shows that the Pearson product moment correlation coefficient for sample data, which is commonly referred to more simply as the sample correlation coefficient, is computed by dividing the sample covariance by the product of the sample standard deviation. So just like we have seen here, here this is the formula. We divide uh, we divide the covariance, the sample covariance by the product of the sample standard deviation of x and the sample standard deviation of y. So now, let us now compute the sample correlation coefficient for the stereo and sound equipment store. That's the data we have above using the data in table 3.6. So we can compute the sample standard deviations for the two variables. All right. So we use this formula. Remember the formula we gave in our sample standard deviation uh, before this class. Uh, that's now I think in our last class. So we use the same formula here that we have s of x, which is the sample standard deviation, given by the root of summation xi minus x bar all squared all over n minus 1. So if we do that, we get the sum for summation xi minus x bar all squared. We square the sum of deviations, we get 20, and then n minus 1, that's 10 minus 1. Remember, we have 10 weeks, so we have 9. So once we divide 20 by 9 and take the square root, we have 1.49 as the sample standard deviation for the weekly commercials. And then also here, the sample standard deviation for the weekly sales we have the same thing that we did do above here, and then we have 566 over 9. Once we compute, use our calculator and divide it, we take the square root and we get 7.93 as the sample standard deviation for the weekly sales. Now, because s of xy is equal to 11, which is the covariance of x and y equal to 11, the sample correlation coefficient equals, using the formula for the Pearson product moment correlation coefficient, we have 11 all over the product of 1.49 times 7.993 using the formula that we have above. Uh, so when we do that, we have the value 0.93. Now, so we're going to look at the interpretation. What does it mean when the correlation coefficient is positive, is negative, and so on and so forth? We know that it is worthy of note that the value for correlation coefficient cannot be more than 1. It can be negative, maybe negative, but it will not still be more than 1, and then it can be also be positive, but still not more than 1. So whether it is negatively correlated or positively correlated, but it cannot be more than one. So here we see the value here, we have the value to be 0.93. So we're going to look at what it actually means. Now, the formula for computing the correlation coefficient for a population denoted by the Greek letter rho. So this value here that looks like P, rho of xy is called rho. So we pronounce it as rho. It is the Greek alphabet that we use for population correlation coefficient. So this gives us the Pearson product moment correlation coefficient for the population data as this. So we have rho of xy. Initially we had r of xy, but here we have rho of xy for the population equal to population standard deviation sigma s of y. Population covariance sigma x of y over the individual standard deviation of x and y. So where rho of xy here stands for the population correlation coefficient, uh, sigma xy here stands for the population covariance, uh, sigma x here stands for population standard deviation for x, and sigma y here is for population standard deviation for y. So the sample correlation coefficient R of xy provides an estimate of the population correlation coefficient. So we explain, we say that in our previous class, we say that because we may not be able to use the whole sample, sometimes it's practically impossible to use the whole population. It is important that we take from the sample and give an estimate. And we also remember, we also said that it is important that when taking the sample, you should be very, very meticulous so that we will not take sample from where it will not give us the real estimate that we're looking for. So the sample correlation coefficient out of xy gives an estimate for the population correlation coefficient rho of xy. Now, interpretation of the correlation coefficient. Now, first, let's look at another example before we go back to interpret the correlation value that we got for the stereo equipment data. Now, first, let us consider a simple example that illustrates the concept of a perfect positive linear relationship. So, this example that we have here uh, it's an example that illustrates a perfect positive linear relationship. So we're going to see by the calculation. So the scatter diagram in figure 3.12, which we're going to look at, depicts the relationship between x and y based on the following sample data. So this is the sample data. We have x eyes, we have 5, 10, 15. And then for the y eyes, we have 10, 30, and 50. Now, this is a scatter diagram that is depicting a perfect positive linear relationship. So if there's a perfect positive linear relationship, all the values will lie in a straight line as we have here. So we see here y, the vertical axis stands for the y values, that's the weekly sales, and no, for the data that we have, and then also the horizontal axis here stands for the x value. So it gives the data we have above gives a perfect positive linear relationship. That's why it gives a straight line. Now, the straight line drawn through each of the 3 points, shows a perfect linear relationship between x and y. So, in order to apply equation 3.15 to compute the sample correlation, we must first compute the covariance of x and y, the sample standard deviation of x, and then the sample standard deviation of y. Now, some of the computations are shown in table 3.8 using the results in this table. We find that. So here is the computation that is done. So when we substitute all the values, just like we did in the first example concerning the stereo equipment, stereo and sound equipment, we discover that we have 200 divided by 2, which gives us 100 here. That's for the covariance. And then for the sample covariance, then for the sample standard deviation for x, we have 5. The sample standard deviation of y, we have 20. So putting them together and then estimating using the Pearson product moment correlation coefficient, we have 100 divided by 5 times 20, which is 100. So 100 divided by 100 gives us 1. So 1 stands for a perfect positive linear correlation. So thus, we see that the value of the sample correlation coefficient is 1. So we're going to look at the interpretation. Now, correlation coefficient explanation. So we want to understand all the values for anytime we calculate a correlation coefficient, and then whichever value that we have, we should be able to understand what it actually means. So here are the explanation. Now, it can be shown, in general, it can be shown that if all the points in the data set fall on a positively sloped straight line, the value of the sample correlation coefficient is plus 1, which is a perfect correlation. That is, a sample correlation coefficient of plus 1 corresponds to a perfect positive linear relationship now between x and y. Now, moreover, if the points in the data set fall on a straight line having negative slope, that's they are slanting to the other side. Remember, when we look at this particular uh, graph here, we see that the data set is slanting this way, let's say to the right. But when the data set is slanting to the left, we know that we have a negative correlation. Moreover, if the points in the data set fall on a straight line having negative slope, the value of the sample correlation coefficient is minus 1. Sorry, this is supposed to be minus 1. That is a sample correlation coefficient of minus 1 corresponding to a perfect negative linear relationship between x and y, between the two variables. Now, let us suppose that a certain data set indicates a positive linear relationship between x and y, but the relationship is not perfect. That is, the value of the sample covariance will be less than 1. Sorry, sample correlation will be less than 1, indicating that the points in the scatter diagram are not all on a straight line. As the points deviate more and more from a perfect positive linear relationship, the value of the sample correlation becomes smaller and smaller. And when the value of the correlation is 0, then it tells us that there is no relationship. A value of a sample correlation coefficient here equal to 0 indicates no linear relationship between x and y. So once we make we done our calculation, we compute the correlation, we discover the value is near 0. It tells us that there is a weak relationship between the two variables. Now, for the data involving the stereo and sound equipment store, remember when we made the calculation, we discovered that we have a 0.93 correlation coefficient, which is close to 1. So therefore, we can conclude that a strong positive linear relationship occurs between the number of commercials and sales. So more specifically, an increase in the number of commercials is associated with an increase in sales. Similarly, a decrease in the number of commercials will also give us a decrease in sales. So for the stereo data, there is a nearly strong positive linear relationship between weekly commercials, and weekly sales. So which means the more the commercial, the more the sales. The less the commercial, the less the sales. So if you are a business person and you are involved in a particular business, maybe you do commercials, and you discover that anytime you do commercials, you get more sales. So the wisdom is you continue doing more commercials so that you experience more sales. Because the wider your coverage, the wider the sales, the wider the product gets more and more known, and then the more and more sales you make. Now, here are some key formulas that we have been talking about from the beginning of our class. Uh, the first formula here we have the sample mean. So the sample mean, for the sample mean we have x bar is equal to summation xi all over n. So if you want to calculate the sample mean, you use this particular value. So let's take note of all these formulas because we're going to use them in our exercises. We'll also use them in those assignments that we give and the assignments we're going to give, the exercises we're going to give today and today to be submitted next week. So let's take note of this formula. So for the sample mean, we have that x bar is equal to summation xi all over n. Whereas for the population, we see this n here, small letter n here means the total number of samples, whereas capital letter N here means the total number of the population. So for the population mean, we have this formula here, mu, which stands for the population mean. is equal to summation xi over n. Now for the weighted mean, we have that x bar is equal to summation wi xi, where w here stands for the weighted, while averages all over the sum of all the weighted averages. And for the geometric mean, we have this value x bar of g standing for geometric is equal to the nth root of all the product of the individual observation. So we have the nth root of x1 times x2 consequently to xn. So the nth root stands for the n here stands for the number of observation you take in a sample, and then yeah, xn here stands for the last sample. Once we take the product and we take the nth root here, we get uh, the value for the geometric mean. Now, also the location of the pth percentile, we use L of p is equal to p all over 100. So p here stands for the percentile multiplied by n plus 1 here. So here for the interquartile range, we have the IQR, that's interquartile range, is the third quarter minus the first quarter. So Q3 minus Q1 gives us the value for the interquartile range. Remember, we said that the interquartile range is a measure of dispersion. These first formulas here are formulas for measures of location. We have for the mean, for the mean, and then this other formulas here gives us measures of dispersion. Dispersion. So we have the interquartile range here. We have the population variance given by sigma squared is equal to summation of the deviations from the mean, population mean, all over n. So remember, we say when we take the square root, we have the population standard deviation. Here we have the sample variance, which is s squared, small letter s squared is equal to the sum of the deviations, sum of the squares of the deviations from the mean, from the sample mean all over n minus 1. The reason why we subtract this one here, maybe in the next class, I'll give us the reason why we subtract 1. Now, just okay, we subtract here, we subtract 1 here as to make room for degrees of freedom. So we'll see that subsequently as we go deep and deep into the course and see, we understand more and more why we need degrees of freedom. So standard deviation, the formula for standard deviation is the square root of the sample standard deviation is the square root of the sample variance, and then the population standard deviation is the square root of the population variance, as you can see here. Then the coefficient of variation is the standard deviation divided by the mean multiplied by 100 in percentage. So this 100 is in percentage. So we get the answer in percentage. Now, also some key formulas continually for the z-score. Remember, we see that the z-score is given by zi is equal to xi minus x bar 1 over s. And then for the sample covariance, which we have talked about today, is given by s of xy is equal to summation xi minus x bar multiplied by yi minus y bar all over n minus small letter n minus 1. Similarly, the population covariance is given by sigma s of y is equal to the sum of xi minus mu of x multiplied by yi minus mean population mean of y all over the number of population, that's n. Now, also the Pearson product moment correlation coefficient for sample data is given by R of xy is equal to S of xy over S of x S of y. And then finally, the Pearson product moment correlation coefficient for a population data is given by rho, that's the Greek alphabet rho of xy equals to sigma x of y, that's the covariance of x and y, over the population covariance of x and y over the standard deviation of x multiplied by the standard deviation of y. So all these formulas, these key formulas that we have here, gives us from the sample mean down to the Pearson product moment correlation coefficient for population data, gives us a summary of all the things that we have been talking about from the beginning of this module. That's lesson 1 and 2, and so on and so forth. So we'll be using these formulas to solve every other any exercise we are giving. All right. So exercises. So our exercises for next week. Remember, we have an exercise at hand that we are supposed to present and submit as well. Remember, we say they are going to be graded. They are they are taking very important because they are going to be graded. They form part of our continuous assessment. So our exercises for next week. Here we have the first one. We say consider a sample with data values 10, 20, 12, 17, and 16. So for these sample values, we are going to compute the range and interquartile range. We have the formula above. Then secondly, two, we say consider a sample with data values of 10, 20, 12, 17, and 16. For these data values, we are going to compute the variance and standard deviation. Then three, consider a sample with data values. Remember, it's sample, 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 which means we are using sample, the formula for the sample. Uh, Take note. So consider a sample with data values of 27, 25, 20, 15, and 30, and 34, 34, 20, 28, and 25. For this data set, we will compute the range, the interquartile range, the variance, and standard deviation. Then the fourth question, we say the average number of times Americans dine out in a week fell from 4.0 in 2008 to 3.8 in 2012. This was gotten from Zaga.com. That's April 2012. The number of times a sample of 20 families dined out last week provides the following data. So this data is data of 20 families that dined out last week. So if you check that, you see that there are 20 from 6, 1, 5, 3 continually to 3 and 1 here. So we have 20 sample uh, data sets here taken from 20 families. So for this data set, we're going to compute the mean and median. We will also compute the first and third quartiles. We will also compute the range and interquartile range. Then we will compute the variance and standard deviation. Then finally, we will compute the skewness measure for this data. Okay, the skewness measure for this data is 0.3. So we'll comment on the shape of this distribution. We'll comment on the shape of the distribution, given this skewness 0.3. So refer back to our notes, our previous notes, uh, and more research to see how you can answer the comments. Then the question, this is the question now. Is it the shape you will expect? Why or why not? Then finally, do the data contain outliers? So we'll do the necessary research and we'll give our results in our next class. Please let us not forget to present them in the next class. Now, so we know that there are a lot of softwares are available for making some of these calculations. So, especially nowadays, we don't usually use uh, manual calculation. We use softwares like the Excel, simple software like the Excel and the SPSS, and so on and so forth. Also, other sophisticated softwares also exist that we can also perform statistical analysis, which include the Stata, the R, the Python, and so on and so forth. So we last week one of us asked whether we'll be using some of these softwares and learning them and see how we can be able to make some calculations. So today we'll see how we can use the Excel options to make some of these calculations. All right, but before we delve into using Excel options, I want to believe that our laptop are already on ground because we'll be using them practically and see how we can use some sample data to uh, get some small descriptive statistics. So, but before we delve into it, I'd like to open room for questions concerning what we have done so far. If there are questions, if there are gray areas that needs to be clarified, uh, the room is now open for some questions. If we are there, we can indicate by uh, raising our hands, and then we throw our questions in. I want to believe that we're all uh, together here. Are we here all?
Yeah, I'm here.
All right. So if there are questions, you can throw them. You can start bringing them now. Questions. Oh, are there no questions? If there are no, okay.
Hello, Jacob.
Hi, Alima.
Yeah, I believe because they joined the class late, so maybe they will have to like listen to the record later and probably address the questions to us later.
Okay. All right. Okay, that will be fine. That will be fine. That's okay. So, okay. Are we all with our laptop here? Our PC?
Yeah, I'm with my laptop.
Okay. That's fine. So, I want us to see how we can use some Excel options to be able to do some of these simple calculations, especially as it concerns the uh, topics that we've been talking about. That's measures of position, measures of dispersion, measures of skewness, and so on and so forth by varied data, that's correlation and covariance. So I believe we can be able to do them. So maybe as we're getting ready, we're logging into our Excel. I would like to give Halima the opportunity to add more from what we have discussed. If she has more explanation to what we have discussed so far from the beginning of the class up until now. So Halima, over to you.
Hi, good evening, everyone.
Yeah, good evening, Halima.
Yeah, thank you. Jacob, thank you for the lecture. It was really insightful. I enjoyed it myself. So my contribution was supposed to be based on maybe the question they'll ask, but since there is no question for now, I don't know. Maybe if they can go through the slide again, if there's anybody that have question, then I can come in. But your explanations are really really simple and easy to comprehend. So if any other person have question, I will be here to answer.
Okay, thank you, Halima. Then let me throw it over to the class. If we have some more contributions, because these questions that we were supposed to ask now are supposed to be some concerns or observations that were phrased from the beginning of the lecture till now, because after today's class, we are done with the first week one and two module. So we enter the second module, which concerns
Hey Jacob, are you there? I can't hear you anymore.
probability and so on and so forth. So that is why it is all right. So I believe we are good to go. So let's log into our Excel. So we will be asking us one after the other so that we ensure that we are all following. So I would like to start with Mr. Ifeanyi. Are you in your Excel now? How about Mr. Jason? You have logged in your Excel.
Yeah,
Ehizo,
with Excel.
Ehizo, okay, Ehizo J, are you on with your Excel?
No, not yet, but I'm putting on my laptop.
Okay. All right. I want all of us to be carried along so that we will be able to get this right. So if we are there, we the first step is to click the data tab on the ribbon.
Okay.
Are we there? Uh, are we there?
Yeah, on the data tab.
All right. So let's try input this data. Can we? Are you all seeing my screen?
Yes, we can see your screen.
Okay. Here we see data A and B. Are we seeing A and B here? We have A graduate and then B we have starting salary. Are we seeing that? We see graduate here and then we have starting salary here. So if you can see, let's input A B. Let's input A B and then let's input one. Let's write graduate under one. Let's write graduate in our Excel. Please, if you are not getting it, let me know so that we'll be able to carry everyone along. So
So
you
please,
type graduate.
can I see the instructions again? Because I've opened data, but I cannot see my data analysis here.
Don't worry. Just input the data first. But can you see the data now?
Okay, graduates. Okay, yeah.
Yes. And then we have starting salary. So you type graduate, then you type starting
Starting
salary.
salary.
Yes.
Okay.
Now undergraduate, let's put the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Are we all carried along?
Yeah.
Are we all together? Mr. Jason, are you there?
Yes, I'm here.
All right. Are you following? Are we together?
Yes, sir. No, I'm having glitches, but I'm trying. I've been rejoining.
Okay. But are you with your laptop there?
Hello.
I say, are you with your laptop there?
Yeah, I'm with my laptop, sir.
And you are your Excel?
No, 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 no. My Excel has not been opening, but I will follow. I will use the video and follow it. I will update my Excel tomorrow.
Okay, it's all right.
I
It's
think
all right.
the whole Microsoft Office is having issues. Yeah.
Okay. It's all right. Sorry about that. So try and do that tomorrow. All right. So the rest, have you inputted the data?
Yeah, only for the graduate.
Okay. All right. That's nice. Let's also do that for the starting salary. That's for one under the other starting salary. The first one, let's put 3850. The second one, I believe that the values are all clear.
Yes, they are. The values are clear.
All right. So let's do that quickly so that we will delve into the um, analysis, the Excel option analysis.
Are we done inputting the starting salary?
Yes, I'm done.
Okay.
Hello. I say I believe that all most Excels the analysis tool pack has not been installed. So if it has not, let's go to that file button that we're seeing up. That file button up. That file button up. Let's click it. Have we done that? So if we click, okay, let me display my Excel screen so that we'll be doing that together. Now, can you all see my screen?
Yeah, very well.
All right, so let's use this this file this dialog box here. Let's click it. So once we click the dialog box, we will see below we'll see Excel options and exit Excel. So let's click Excel options. So if we click Excel options, by the left here, we see another dialog box which has popular formulas, proofing, safe, advanced,
Sorry,
customized.
sir. I don't have this your type of screen, no. So I don't have it. It's
Okay, can you project your screen? Let's see.
yeah, okay, let me connect my internet.
All right, Mr. Ifeanyi, are you? Is it clear? Do you have that?
Yeah, it's okay.
All right. So if you
Please,
are there,
I'm using 2019. Which one are you using, sir?
okay, I can't recall, sha, but I can't remember. So you
I
don't
think
have
you have not clicked on data.
click on
I
data,
should
ma.
click on data. Hey, I've
Yeah,
clicked on that data, but I've not done data analysis.
yeah, that's
Because
what
I
we're
don't know where
saying.
they are.
Once you click this file here, you don't have the file, the option for the file.
No, I don't have the option for the file. It's not on my ribbon here. It's not there. Let me project my screen so that I see it. I think I'm how do
Okay,
they
all
do
right,
screen share? Screen
all
share,
right.
how do they do? So how do they do screen share again?
You go to share.
Click on present now.
You go to, yes, present now.
Okay, let me open Google. Okay, it's what's up. Hello, Grandpa. Hmm? Hello, Grandpa. Grandpa, it's not Grandpa. Oh, yeah, move you out from here. Come on. Public policy.
You have to join the meeting with your system first.
Yes, that's what I want to do now.
Okay.
All right. Okay. Okay. Okay, sir, I've joined now.
All right, pretend so that we'll see your screen and we'll direct you on what to do.
Hello. Hello. Hello.
Okay.
I do all of my Hello.
Thank you.
Madam, mute one of the mics. Mute one of your mic.
Hello. Mama.
Hello, madam. Can you mute one of your mic?
Well, let me put this one up. Is it okay now?
Yeah, it's okay. So go to present now.
Please, are you seeing my screen?
It's down.
Yeah, I can see your screen.
Okay, so this is it now. You can see file, home, insert. I don't have
Okay. I can see, but I can barely see it clearly.
From here now, you can click on File, the ribbon called File. Yes. Scroll down.
Go to
Down.
add-ins. Okay, down to options.
But I can't see the last option there you have. Go to options. I think we have same. Go to more. Yeah.
All right, so go to add-ins. All right, then go to Excel add-ins. You see Excel add-ins down. Now see it down. You see manage. Down, almost the last. You click on that
Scroll.
arrow. Scroll. Click on the arrow down. Yes. Then you go to Excel add-ins. Okay, yeah, okay. Then go. Now you click on all the analysis toolbar. Click on everything there. Then press OK.
Okay, so what's next now?
All right, so you see that you have mean, median, mode, variance, and standard deviation.
Yeah, I was the one that put this one here.
All right. Okay. So I'm sure everyone has done the same. So you can stop presenting now so that
No, sir.
okay.
Oh no, sir. What I'm trying
Hello,
to find
sir.
out now, what of that thing you were scrolling down? Is it all here now?
Come again.
I said the menu that you were showing us. Is it now here on my ribbon?
Yes. It's here now. It has been activated. The analysis toolpack has been activated.
Okay.
You can see data analysis now.
Okay, right. Okay.
Yeah.
I'm looking data validation. Where is the data analysis?
Towards the end.
It's what if analysis that is here.
Please,
Manage data
I need
model.
I need assistance.
You need assistance too?
That's the data analysis.
So I need assistance.
Okay. Which area
Hello?
do you need assistance? Yes, we can get you. Which area do you need assistance?
Yeah, when I get to Excel adding, after that, what do I do?
Okay, from Excel add-ins, you will. Did you click? Did you click Excel? If you can, If you can present your
Yeah, I
screen so that
clicked
we see.
Excel add-ins and I saw Excel add-ins inside
Okay.
the Excel add-ins. So I
Fine.
clicked on it. It brought out a dialog box, name, location, type with the active application add-ins. So I've not chosen anyone yet.
Okay. I do I'm
The
presenting.
analytics.
I do I'm
No, I'm
presenting now.
not. She's the one. No, I'm
Okay.
not.
Okay.
She's the one presenting.
Okay.
I
Maybe
think
she
she's
should
showing
stop.
our.
Have you taken a cue from her presentation?
No, no, I didn't see it clearly. I just checked it and I didn't see it clearly. So I'm still in that page.
Okay. All right. So,
You've
I
seen
think
data
what.
analysis now. Can you stop projecting? Okay. Can you project your screen so that we can see what you're talking about?
Okay, okay. It's not sharing to share tab.
Do you have a problem sharing your screen?
I think so. It's not
Okay, you see,
sharing.
you you can see
I've
present
shared it.
now. Can you see present
Present.
now?
Okay, let me go back. Yeah, I've seen present now.
You can click on it.
Yeah, I've clicked on it. I'm seeing Chrome tab, window, entire screen,
So click on window,
window. Yes.
then click on your Excel. All right.
Okay.
You see Excel add-ins. Click on go.
Go. Okay.
Click on all the add-ins available. Just check the boxes.
Okay.
Okay. Yeah, that's all.
Okay. Okay. So I should stop sharing.
Yes, thank you. Hey Jacob, can we continue?
All right. So if we have done that, we will continue. Just take a look at my screen. I'm going to present again. All right. So if we have done that, let's by the side. Let's go to from our Excel from our Excel. Let's go to the site and impute mean, median, mode, variance, and standard deviation. Can we do that? By the side, let's put impute the mean, just like as we have it here, the mean, the median, the mode, the variance, and standard deviation. Let's do that quickly, please. If you have trouble
We should
doing any,
enter it. We should enter it manually.
yes, enter it manually.
Hello, sir.
Yes, enter it manually.
Hello.
Yeah, are you there? Have you
Hello.
done that?
Yes, I've done my own.
All right. Let's wait for the rest so that we can go together.
That one has been done. What do we enter again?
All right. So if you have done that, go to uh, the in front of the mean. Are we there?
Yeah.
Yes.
Okay. Then put equal to where you have the mean, just like we have it. Are we there?
You mean the next column after the.
Yes. Yes. The next column after the mean, just like we have it on the screen.
So I not seeing your screen well. Oh. Okay, you are seeing it now. It's well. I've seen it now. I've seen it now.
All right. So in front of the mean, where you imputed mean, have you seen it?
Yes, sir.
So you go to the next column. Here I'm having column E. That's where it is. Column E. Can you see column E? Where I'm pointing now.
Yeah, column E.
Aha.
Yes.
So there where there's mean, you put equal to. Now if you put equal to and you start typing average, you see an average. Some values will appear. Are you there? You should start typing average. Are you there?
Yes, sir.
All right. If you type average, you double click. It will give you an uh, open bracket. Are you there?
Yeah.
Yeah.
Now you take your cursor to starting salary. Your cursor will now will look like a box, will look like a cross. You take it to starting salary. Okay, let me project my Excel
Yeah.
so that I'll show us. Okay,
Yeah. Very clear.
we have done that. All right, so you right click and toggle down to you right click from the value 3850, and then you toggle it down to the last value, which is 3880.
Okay.
Now you go to the second one, which is
You
median.
press enter.
Yes, enter. Then you go to median.
It has given the answer. Oh.
Yes, yes, yes. Then you go to the second one, which is median. Are you there?
Yes, sir.
Yeah.
All right. For the median, you press median. The same thing. You do the same thing. Equal to. You put equal to, and press median, and do the same thing. You toggle from uh, the 3850 down to 3880. Have we done that?
Yeah.
All right. We have seen the answer, right?
Covariance
All right. So you do the
for
same
the
thing for
mode.
all of them. Then
Okay.
we'll talk after you're done.
For variance, so I'm not seeing variance. So I'm seeing covariance.
Okay, you're seeing
Covariance
covariance.
P and covariance.
It's not put.
Covariance P. Covariance P and covariance S. I'm not
Okay,
seeing variance.
that's what you're seeing.
Yes.
Let me check.
Is it to get the variance?
Yes.
If you use equal sign and you type that
Did you
val, it will show variance
did
dot
you
S.
press equal sign first? Don't forget you
Yeah.
have
I
to press
press equal.
you have to and then put VAR. You see VAR there.
VAR.
Yes, you don't see it.
V arms. Okay. VAR. Okay.
All right.
Thank you.
That will give you the variance.
For standard deviation, is it an abbreviation?
The standard deviation. Did you put equal to?
Yes.
All right. You see STDEV.
STD3.
Yeah, STDEV dot S.
I saw STD dot X.
Yes.
Okay.
Is it working? If it's not working, just remove the Just remove the dot S. Just put the one you have.
Why do I activate my back button and front button? So if I'm making
So
mistakes, I'm not seeing it activated.
how do you activate your what?
The back button and front, as in to erase whatever it is that you have done.
Okay, I think you need to redo it again. You understand?
Yes,
Can
yes,
to
I
undo
have to start
to
over
undo
again.
and redo.
Or
Yes, so
you
undo
can
and redo.
undo and
Exactly,
redo.
that's it.
Yeah, you can just do
How do I
control
activate it?
control Y.
Do
Control
you see
Y.
the file ribbon on top of it?
Yes, yes,
Yeah.
yes,
Did you see the arrow pointing an arrow pointing to the left?
yes. I've seen it. I've done it. I've done it.
Okay.
Thank you.
Yeah.
But if I do the variance there, it's bringing out name,
It's bring, it's bringing out what?
name.
Name.
Yes,
Maybe you're not doing it properly. Just did you press equal to sign?
yes, I did.
Then VAR.
Okay, VAR. Okay, okay.
Yes.
I was spelling it fully. But I still doing the same thing. No, still bring that name. Still bringing out name.
Are you sure you're doing it properly?
Yes, I am. You see, I've done it for the other three main media mode.
Okay.
Equals to var, right?
Yes.
Then I open the bracket, right?
Yes.
Then I click on
No,
this and
equal to val dot s. There is a dot before the bracket.
please, what answer did the person get? They get a decimal. I got 27440.9.
Yes.
Okay, it's all
That's the
right. So
answer.
I'm okay.
Okay.
Okay. So what about standard deviation? I would say equals to what?
Equals to
ST,
STD EV.
STD,
EV.
STDEV.
Did you see the option there?
Option where?
You're supposed to see the option. Once you start pressing STD EV, you
Yes,
see the
I've
option.
seen the option. Yes, I've seen it.
Aha, aha. So you click on that and do that.
Okay, I've done it. It's okay.
All right.
I got a decimal there too. Okay, thank
All
you.
right. That's fine. That's fine. Now, I'm having a power outage here. My system is about running down. So I don't know. I wanted us to use the Excel server add-ins to see how we can get some to do some histogram, some other analysis. I don't know how I'm going to do this now. So here we also have for the covariance and the correlation. We can also get it using the same method. Can we all see my screen?
Yes.
Yeah,
Yes.
yeah.
So we can also do the same thing for the covariance, the sample covariance, and the sample correlation. So I'll give that as assignment so that when we come in the next class, we will present it. We'll see what we get. Is that okay?
All right, sir.
Then also we can also do it in this way. I will send the material. You will find it in the drive, and then uh, I also put it in the learning LMS, the learning online learning platform. I also put it there so that we can check and see what we can well how we can do it. Is that okay?
It's okay, sir.
Great, great.
All right. So once you use the from the assignment that we gave today, once you use your normal hand and calculate, you also use the Excel server options to uh, to um, to confirm whether the answer is correct or not. I believe that's okay.
How, sir? I don't understand that.
I mean, the assignment, we are going to solve them we're going to solve them, right? Not with the,
Yes.
yes. So once we have finished solving, we can also use this Excel solver options to see whether the answer corresponds.
Okay, okay, okay. That's this one you
Yes,
already
that.
solved here already.
Yes. So we will
Okay,
use,
okay.
yes. You remember the assignments now. We give them in the, we see here is number one, two, three. One, we're going to look for the range and interquartile range. We have two, three, and then four. We have seen the assignment, right?
Yes, sir.
All right, so we'll do the same thing. So when we come in our next class, we'll see how far we have gone. Yeah, I'll also advise us that we can do as much uh, practicals as possible so that we get ourselves acquainted and more familiar with these Excel options. So that once we start using some other softwares, we will see we're already familiar with some of these things and it will be easier for us to use them.
Great.
It's all right, sir.
Okay. So I'll hand over to Alima. Alima, are you there?
Yeah, I'm here.
Yes, you can continue from here.
Okay. Um, please, for the last week exercise, I don't know if there is anyone that actually attempts to do it. Did any of us attempt to the exercise I was given last week?
Yeah, I can't remember any exercise that was being. I think it's only the presentation on Thursday though, that they talked about. But we give you assignment last week.
Yeah, there was an exercise for us to do.
Can't remember.
Okay. Mr. Ifai,
Yeah.
do you remember us having an exercise to do?
Yeah, my system went off. My network cut off before the end of the lecture last week. I have not checked it. I'll do that this night.
Okay.
Cavalry.
So what should we do now? We should leave it till tomorrow
That
so
will
that
be
we can
great.
actually look at the exercise and maybe submit what you have your attempts to me before
Okay.
we can actually.
Okay, ma, if you can even post it on the platform, can't remember the exercise. Though. I'm so sorry. So many things to do at the same time.
All right, I'll post the question now on the group chat, on the WhatsApp group chat.
Okay, okay. Please,
Okay, that will be
thank
All
you.
right. You're welcome. So you can actually go through the record. If there is any question, you can send us a message
okay.
The record, what
anytime.
record? Okay, the recording. Okay, okay, okay. Yes,
Yeah.
yes, yes. Okay, that's good. Thank you
Okay.
very much.
Yeah.
All right.
In addition to that, I think we how many of us have access to the online learning platform?
We don't know much about that. Please, can you link us with it?
Okay, Halima, I thought they have been visiting that site now because all the assignments and all those things are posted there.
I think
Okay,
they initially have trouble accessing the LMS, so we are using Google Drive for now, and all materials are being posted on the drive.
Okay, okay.
that link you sent.
Yeah, a link was shared. A link to the drive was shared in the group chat, the WhatsApp group chat.
Okay, we access it through that link, right?
Yes, you can access to the link. So I'll post the assignment on the WhatsApp group chat, then on the drive too.
Okay, thank you.
Then
Yeah, well,
this one,
we'll also post today's
today's
assignment too.
one, yeah, today's one is making it two exercise now that we have to do.
Okay. So what we are going to listen to the lecture first of all before we attempt.
Yeah, that will be fine.
That's how it is.
Thank you very much.
All right, thank you everyone. I think we can, if there is question, but if there is no question, we can end today's class. Hey, Jason, are you here?
Alima, Alima,
Yeah, I'm here.
please, I'm trying to do my, I don't know if something has been disabled or enabled. I'm trying to save this particular workbook, but I open my file and I go to save as, and this screen is blank. I've not been able to save it. I don't know why.
Okay, can you share?
Okay, let me go back to my internet.
Mr. Ame, you're welcome. Hello, Mr. Ame.
Okay,
And also, I think we have a problem with us filling our attendance form. I do share an attendance form in every class, but I don't know. Is it difficult to fill? I'm asking everybody.
where do you normally drop the assignment?
I've not seen it once, so
I do drop it in the message
Me too,
box
I'm not seen.
during the meetings.
all the been attending, I've not seen it too. Please, oh.
Kalima, can you redrop it now so that they will learn how to visit it and take the attendance so that
Yeah,
we'll
I
guide
will.
them. All right, please do that so that we'll also guide them as well.
I thought you feel it for us, oh.
Alima,
Yeah, I'm here.
okay, I see my screen now.
Yeah, I can. Click on file,
Okay, look at it. Uh,
then save as.
it's blank.
You just give it time to load.
Mr. Ifeanyi, can you mute your mic? It's like there's some interference. Uh, so, Alim, have you sent the attendance?
I'll send it now.
Okay.
It's not coming. No, look at it.
Go back. Let's see.
There's a file option on top. Can you click on that? Yes. No, on top.
Click on save as again. Let's see whether it will work this time.
Double click.
I don't know why it's not coming up.
Can you go back again? Go back again. Let's see something. And click on file. Now, choose the. I think you should choose the location or something like that.
I to choose what?
Click on save. Let's see whether it's to see show same thing. I don't know why it's blank from your end. It's supposed to come up with options on where you want to save it in your drive.
Yeah, that's what's supposed to happen, but I don't know what's happening now.
Okay, go back again. Click save. Do a new. Just click that blank. Oh no, don't go to save as. Just go back again. Go back again. Let's try something. Click on save on file. Click on that blank new document, that blank document. No, no, that blank. There's a blank document on top. There's a yes. Click double click.
This is for a new workbook.
It's work.
Let
I
me
don't
try
know.
and save this one. Let me save this one that it show.
Yes, try and save this one. Let's see.
Ah, it's the same thing. Oh. What's the problem? You can't lose that work.
Just hold on, go back. Click on this save icon at the top of file. Okay. This click location, just click on it. Let's see. Choose a
Just click the
location.
file name now. File name.
Where do you want to save
Wait,
it?
you have not saved. You have not given the name, the file name. Yes, so give the name now. Then save it. You can save it here. You can save it anywhere. You can save it. So if you want to, you are looking for it, you go to documents. You see it there. Is that okay?
So let me off this one, go and save down. Because this one is a new work program. So let me do this one now.
All right. So you are good to go.
Okay. Yeah. Okay.
You can try the save as option later. I don't know why it's not working from your end for now.
Okay, I'll just close it now. My laptop is trying to restart. Maybe that's a challenge.
Oh, you have to restart your system. You have to update
Let
everything.
me update it. Okay,
All
thank
right.
you,
So
Alima. Thank you, Mr. Shuki.
Yeah,
let's
you're
let's
welcome.
try and sign the attendance, please.
So I do drop the attendance link, the link to the attendance. So I do drop it on the message box in every class. I don't know. I don't know why we've not been feeling it, but now that I get that you guys said you don't used to see it, you can check now. If you check the message box, the meeting message box, you see a link I shared.
You go to in call messages.
You see an icon that shows chat with everyone. By the right end of your screen. Can we see? Can we all see it?
Yes, I've seen it. This course is statistics for economics, right?
Yes.
Okay, mine is done.
So you ensure that you enter your full name and your email address. So you not
Okay.
Yes,
there's a
I
What
enter
of
my
this
phone.
one? Hello?
yes.
Hello? The other ones I attended, the other classes I attended, and I didn't write my attendance. What happens now? Can I write?
No, you can't fill that. I've actually been filling it manually. I do come online and capture those who are present and fill it
Okay.
manually. But now we all have to fill it ourselves.
Okay, I'm done. Can I go now?
Yeah,
Just
thank you.
wait
Okay,
a
good
bit.
night. Bye bye.
All right.
Yeah, bye.
Mr. Jason, have you filled the attendance? Mr. Jason, have you filled the attendance? How about Mr. Ame?
I've filled it.
It's all right. So we have given some exercises. I believe you will check through. You go through the drive. the link to the drive, and you will see them, that the exercise for last week, and then also the exercise for today. And then let's endeavor we follow through the video and replicate whatever has been done today. That's for those of us who came in late. Then we should also ensure that we use the Excel to be able to uh, calculate those measures of position, dispersion, covariance, and correlation. So if we do that, I believe that we are good to go. So without any more questions to ask, uh, we should thank you all for uh, attending the class. We will meet again in our next class. Do have a blessed night and have a great day ahead.
Thanks.
All right. Good night, everyone. Bye.